Good afternoon, students. Let's start with the class. There is no current, so it's little bit dull. But we will wait, start solving. Okay. Okay. So previous class we had solved first 5 problems. So we are on page number 4, sixth problem now. The sixth problem says a fair coin. So I told you this term word fair will be there, or sometimes that unbiased. So you don't have to bother so much on that fair word. So there's a coin. Okay. So on that coin, what is there instead of head and tail? What has been marked on that face? On one face, one side 1 is written, and on the other side of the coin 6 has been written. Okay, so this is on the other side. Then there's a comma. Okay, then a pair die, one more die has been tossed. So what is happening? A coin and a die has been tossed at the same time. So what is the coin having? 1 and 6 written on it. Same way, what is there on the die? Die will have all these options: 1, 2, 3, 4, 5, 6. Okay, so what all combination can come? Either one can come. So if you are throwing a die, this or this. Same time, what can come along with this? It could be 1, it could be 2, 3, 4, 5, 6 on the die. Okay, so we'll write a sample space. So we'll start with 1 first. So if 1 is on the coin, what all possibilities can be there on the die? So it could be this. So this is for the coin, and this is for the die. Same way, 1, 2 can come, 1, 3, 1, 4, 1, 5, 1, 6. Same way, which other combination can come? If you throw a coin, 6 could come. And on the die, it could be 1, it could be 2, it could be 3. So this is your sample space. The first one tells you about the coin, and the second one tells you about the die. So these are the all possible these possibilities which can come up if you throw a coin and a die at the same time. So how many elements are there? We have to check. We have to find a probability, no? N of S will be 12 elements. Count this: 1, 2, 3. This whole thing is one element. So there are 12 elements. Now find a probability that the sum of the numbers turn up is 3. The first one says the sum should be equal to 3. So take up only those pairs where if you add it becomes 3. So if you notice, this is the only pair, if you add will become 3. This is giving you 2. This will give you 4. This will, if you add, will give you 5. So sum is equal to 3 means let A, any letter you can use. So that's the only pair. So what is the n of number of elements in A? Just one element is there. So we'll find a probability. So what was the probability formula? Number of elements in A upon your total sample space. This is a fixed formula. So 1 upon 12. This is 1 and this will be 12. This is the first answer. Now do the second part. Second part says sum should be 12. So pick up those pairs for which sum will give you 12. I think that this is the only pair which will give you 12. Rest all this will give you 10, 11. You can name this letter as B also, no problem. Or again here. Number of elements in B is 12. So what will be the probability? 1 by 12. N of P upon N of S. Anyone having doubt in this? Cannot. Then the seventh question. Suppose each child born is equally likely to be born a boy or a girl. Okay. So there are 50% chances that it could be a boy or that could be a girl. Now consider a family with exactly 3 children. Okay, so find a probability that exactly one. So these are the conditions. So before conditions, we need to find sample space. So how many children? 3 children. So we have to try the combination for 3 children. It could be like boy, girl, boy, 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 all 3 boys, or 2 girls, 1 boy. Okay, so looking out. So how many possible combinations? It's like same like tossing of 3 coins, like head and tail, no? Like that it will be boy and girl possible combinations. So 2 raised to 3 will be how much? 8 possible combinations you should get. So how we are done for the this coin, 3 coins, same way you have to do. First you can write 4 boys, 4 girls. Then 2 boys, 2 girls. 2 boys, 2 girls. 1 boy, girl. Boy, girl, then 1 each. So if you have noticed, every possible combination is unique. So what could be the 3 children be? All 3 could be boys, or first 2 could be boy, the third one could be a girl. Or first would be boy, then girl, then boy. So these are all the possible combinations possible with 3 children. So the sample space will be all this. So write horizontally everything. And number of samples this elements in S will be 8. N of S is 8. Then now the first sub question. Exactly one child is a girl. So check over here, or you can check here also, no problem. Exactly one child is a girl. So pick up only those where there is only one girl. So here, this one, and this. So these are the only possibilities where there is only exactly one girl. So write those one. So how many elements? 3. So what will be the probability? 3 out of always your sample space. Second one, at least 2 girls. So at least 2 girls means 2 or more. So pick up those pairs from here where it is having 2 or more girls. Maximum could be 3. 2 or 3 girls. So here 1, 2, 3, 4. Because this is more than 2 girls. You cannot take this because this is less than 2. Here there are 0 girls, so you cannot pick up this also. So n of b is 4. So your probability is 4 upon 8, which is half. Then the third one. No child is a girl. No child is a girl means all boys. So there's only one possible combination. All boys is BB. Rest all are having girls in that. At least 1 or 2. No child is a girl means all boys. If no child is a boy was given, then this would have been all girls. So probability will be just one element, no? 1 out of 8. Eighth question. Find a probability that a leap year is selected at random will have 53 Sundays. Okay. So this actually question wise it looks very difficult, but answer is very simple. In a year, always there are in a normal year, okay. So there will be always 52 Sundays, 52 Mondays, 52 Tuesdays like this. Okay. So this works even for Monday, Tuesday, Wednesday. This question can come with Sunday or can be with Monday, Tuesday, any of the day. Answer solving part will remain the same and final answer will also remain the same. So now only they have given it as a Sunday. But even if it was given as Monday, so you have to do the same thing with Monday or Tuesday, whichever day. So it works for every single day. So in a year, there will be 52 Sundays compulsorily. So 52, okay. So 52 and into 7, because 7 days in a week, na? So that will be how much? 4. That turn out to be 364 days. So in the 364 days, there will be 52 Sundays which will be coming up. Now, leap year has how many days left? Leap year has 366 days. A leap year will always have 1 day extra than the normal year. Okay. So out of that, 52 Sundays are already compulsorily there. Now this is 360 days, 6 days. So remaining days, how many will be there? Remaining would be 366 minus 364. There are 2 days which are left, which could be anything. Okay, this could be anything. We'll check. The 2 days could be, means the year has ended and the last 2 days now. Out of this, 52 Sundays are done. Till 364, you know that all the 52 Sundays were done. Now these two last, like at the end of the year, 30th and 31st December, you don't know which days it could be. So that could have been Sunday, Monday. Okay. So that's the sample space which we'll be getting. The 2 days, the last 2 days. Then Monday, Tuesday, it could have been. We don't know what is it. Then Tuesday, Wednesday, it could be. Wednesday, Thursday, it could be. Thursday, Friday. Friday, Saturday. Or Saturday, Sunday. Okay. So this could be the remaining last 2 days. So total sample space, how many combinations could be there? 7 combinations. So in these 7 combinations, now this is your normal sample space. The main question which has been asked now is probability that one Sunday is the extra Sunday. So 52 Sundays were already done. So what are the chances that the last 2 days could have a Sunday coming in that? So A is 53 Sundays. Means one extra Sunday other than 52. This is for your understanding. 52 are compulsorily there in the year. So it means the last 2 days, what are the chances that it could be a Sunday? So check over here, which are the possibilities that there could be a Sunday, this one and this one. So there are 2 possibilities. Sunday, Monday or Saturday, Sunday. If this possibility comes, then a Sunday will appear in the last 2 days. So therefore, N of A will be 2. So P of A will be 2 out of 7. This is a fixed answer. If you want to even by heart, whatever you want to do, it will never change this answer. 53 Sundays, answer is 2 out of 7. Now if they had given instead of Sunday, if they had said Monday, okay, same answer it would have been. The only thing here you would write it as Monday, sample space will remain the same because the last 2 days could be anything. This. So if they had said Monday, which you would pick up this and this combination. Okay, again it would have been 2 only. Suppose if they had said Thursday, so A would have been what? Wednesday, Thursday, Thursday, Friday, still 2 combinations only. So every day, whichever day they ask for a leap year, answer is fixed, that is 2 out of 7. Now I had not given you that question. I'll just add on there only the question number. B part you can do. That was A part what we had solved. Now B, you can simply add 8B. Same thing, find probability that if a normal year is selected, suppose if there is not a leap year, okay? If a normal year is selected at random, will contain same question 53 Sundays. So either a normal year can come or a leap year. Definitely, there is nothing else which can be asked. So normal year will have how many days? Obviously 365 days. And 52 Sundays of a week. So total how many days will become? This is compulsory. So that will be 364, which I have already calculated. So remaining days will be how much? The last day of the year. So out of this 52 are fixed. But we are looking at for that one extra Sunday other than 52. Remaining day will be the last, only one day will be left now. 31st December will have one day left out of the normal days. So that last day could be, now there will be no 2-2 combination. Previous problem there were 2 days, so that's why we could take those combinations: Sunday, Monday, Tuesday, Wednesday. Now it's only one day. So either it can be Monday or starting with Sunday, whichever way you want. Could be Sunday, it could be Monday, we don't know. Could be Tuesday, Wednesday, Thursday, Friday, or Saturday. So this is your sample space if there is one day. Still the answer anyways n of s is 7. So this remaining day could be one of the 7. And now what will be A? 53 Sundays. That is 53 Sundays. So there's only one option out of the sample space where there is a Sunday there. So P of A will be 1 out of 7. So for a normal year, even if it is a Monday, Tuesday, Wednesday, whichever day, answer will be 1 upon 7. And for leap year, it is 2 upon 7. If anyone is not understood, can ask her. This 7 was why 7 days a week. So it's all gone like till there, because the other days would be Monday, Tuesday, Wednesday. We were interested on this. No? The ninth one. Tickets numbered from 1 to 20 are mixed up. And then a ticket is drawn at random. So there are tickets on which there are numbers 1 to 20. So there are 20 tickets in short. And whenever you pick up, it could be anything one out of those 20. So what could be a sample space? It could have been 1, it could be 2, 3, 4, anything up till 20. I'm not writing all the numbers like 5, 6, 7 up till 20. It could be. So there are 20 tickets in the box. So n of sample space would be 20. Now they all mixed up. So you're picking up this randomly. What is the probability that a ticket has a number which is a multiple of 3 or 7? So this is A part, multiple of 3, or it can be multiple of 7, not and. We'll do both otherwise. I'll check. Second one anyways would not be possible, and means it would be empty. Still we'll do this. We'll consider multiple of 3 and 7. So A will be, from this pick up all the multiples of 3 or pick up all the multiples of 7. It could be both. This is also option available, or means. So 3, 9, okay, 6, 9, 12, 15, 18. And what are the this multiples of 7 also? It could work both, or also you can pick up 7, 14, done. So these are multiples of 3, these are the multiples of 7. 1, 2, 3, 4, 5, 6, 7, 8. The answer is 8 out of 20. So or means both you can take. Second option, I'll just add on one question. Second is, you can consider B. Multiple of 2 and 4. And is there now? If it was or, okay, if this was or, you could take what? 2, 4, 8, okay, 2, 4, 6, 8, 10, 12, and then multiples of 4 also. But now this has to be compulsorily a multiple of 2 as well as 4. How to read? 2 as well as 4. So B will be, you cannot write 2 only because this is not a multiple of 4. And means it should satisfy both the numbers condition. So 4, 8. So this is a multiple of 2 also as well as 4 also. The answer will be 1, 2, 3, 4, 5. 5 out of 20. This is 1 by 4. Tenth one, a coin is tossed. Okay, so a coin is tossed. Of course, when a coin is tossed, there are two options, head or tail. If a head comes up, a die is thrown. So if a head comes up, we have to do the second experiment. So a die is thrown. So when a die is thrown, what are the options? You could get 1, 2, 3, 4, 5, 6. No. If a tail comes up, a coin is tossed again. Again, a coin is tossed. So when your coin is tossed, what are the options? It could be head, it could be tail. So this is for the die, and this is for the coin. So if a head comes up, you are doing the second experiment, and out of that, this can come. If you got a tail, you are doing the second experiment of tossing a coin, therefore. So what are the chances? It could be head or tail. So write your sample space. So it could be head comma 1, it could be head comma 2, it could be 3, head comma 4, or it could be tail comma head, be tail comma. This is a sample space. How many elements together? N of S will be 1, 2, 3, 4, 5, 6, 7, 8. Now your conditions. Find a probability of two tails. Where in the entire thing where there are two tails, only over here. So N of A is 1. So what will be the answer? 1 by 8. 1 upon the sample space. A head and a number 6. So there is only one option. Head and a number 6. Just one element. Therefore, P of B is also 1 out of 8. And the third one says head and an even number. So what all are the options? Head and even number is this, this, and this. Even number along with the head. The third one, you can name it as C. Head comma 2, head comma 4, head comma 6. So how many elements? 3. Therefore, probability will be 3 out of 8. Eleventh one. Now, this is not a normal die. Now they are changing the die. Okay. So there are 6 spaces. Okay. With number 2 faces have number 1 written on that. 3 faces have number 2 written on that. So there are 6 faces now for die. And 1 face has 3 written on. So 4, 5, 6 has been erased. Okay. From that die, 4, 5, 6 has been erased and replaced by these numbers. So what could be a sample space? Sample space could be 1, okay, you can write first like this, 1 comma, it could be all the this or it could be this. Okay, so you can count all. So instead of 4, 5 and 6, what it will be now? It could be 2 to this. The number of sample space would be 6. Okay, so there will be no 4, 5 and 6 number here because that has been replaced by other numbers. Now the first option is what are the chances of having 2 as the number? So how many numbers are there? That is 3. So P of A will be 3 out of total 6. Second one says 1 or 3. Or means you can take both. 1, there are two options. 3. So anyways again 3, n of B is 3. The probability will be 3 out of 6, which is half. 1 by 2. Third one, not 3. Not 3 means I don't want this. So other than that, what are remaining? If I don't want 3 means I want this. These 3 other numbers which are left. This is, so that will be 1 comma. This is for not 3. So elements are how many? 5 elements. The probability is 5 out of 6. So if they had said not 2, these all 3 would have gone. And what would be the C? 1, 1 and 3. The last one, 12th one. In a single of throw of 3 dice. Okay. Now, as long as there were 2 dice, it was very easy. How much in 2 dice? What was the sample space? Sample space is to be 6 into 6. 36 pairs we used to get, no? 1 comma 1, 1 comma 2, like that till this, and the last one till 6 comma 6. So that was simple. At least that much we could do, writing 36 pairs. Okay. Now what they are saying, 3 dice. 3 dice will be, sample space will be 6 into 6 into 6. So how many pairs you will get? 3 dice, 36 into 6. So that will be 216. So you cannot sit and write 216 pairs for exam. So if there are 3 dice, you can straight away say the number of pairs inside a sample space will be 216. Now, what is the condition? So how it will go like this: pairs 1 1 1, 1 1 2, then 1 1 3, 1 1 4, because there are 3 dice, no? And so on till 1 1 6. Then it will be starting with 1 2 1, 1 2 2, like this, and then 1 3 1, so on till this combination. So actually the pairs will go like this in pairs of 3. Now the condition is, which are the numbers which can give you a total of 5? Which set? Okay, which pairs will give you a total of 5? So actually you don't have to sit and look into this pair. So 3 numbers when you add should give you 5, total of 5. So we'll check which are the maximum possible numbers on a die. 1 2 3 4 5 6. So we'll try to add any 3 numbers and see which are the numbers which can give me a sum of 5. We'll consider. If we check, first we'll keep this as 1. and then second one also will keep this as 1 and check. Now to make it a 5, 1 1, which number can give me 3? This is giving me this. Then I'll try with 2. If I am putting 2 here, how much I'll need? 1 I'll need. So 4 it is becoming, no? So it will be 2. Okay, so these only we have to arrange among themselves now. So if I'm starting with 2 here, this could be 1, this could be 2. If I'm starting with 2, this is 2, and this can be 1. I cannot try with more than that numbers, okay? See, 4 if I take here, even if I take 1 and 1, I cannot start only with 4 number. Why? Because the minimum number which I can put here is 1 and 1. 4, 5, 6 it will become. So I cannot take 4 in this. The only numbers which I can try is with 1, 2 and 3. Because the moment I take 4, it crosses the sum of 5. Then I'll start with 3 and see. 3, 1, 1. If I'm taking 3, 2, it is not possible. Because if I put 1 here, it will not work. One more option is there. 1, 3, 1. Your total 6 possibilities. You try any other numbers, you will not get after adding sum of 5. These are the only possibilities. So therefore, n of a will be 6 upon 260. So 1 by 36 will be your answer. Now we'll move on to the problems based on permutations and combinations or selections. So if you have done the combination chapter understood, then these problems will be very simple. Okay. The first one based on combination. So there are 5 marbles which are drawn from a bag which contains 7 blue and 4 black marbles. So from here, how many am I removing? 5. Which ones? We don't know right now. We just have to check. Now, total how many will become? 11 marbles. So always for probability chapter, we have to find a sample space. So sample space will be without any conditions. So don't jump onto the conditions first only. First always find a sample space. So don't look at any conditions right now. So we'll find sample space. What is the sample space? Don't go to see whether they are blue, black. Total how many marbles are there? 11 marbles. We are picking up how much? 5. Okay. So that can be done in how many ways? So that's always a sample space. Now it will not be in the set format like this. You cannot sit and check all the combinations. So now straight away. So when we are selecting 5 out of 11, so this has to be written as 11C5. and then calculate. NCR formula 11 factorial upon n minus r factorial, so that is 6 factorial into r factorial. Okay, so either you calculate first only the number and keep, or later when after dividing you can cancel. Okay, like this only you can leave time being. Later again you'll have to divide your normal a by this, so that time you can cancel. Up to you whether you want to calculate and write a single value and keep. Now we'll start with the combination. So this is all the sample space. So now your first condition is all blue. So you can write it as n of s also straight away. So all blue means 5 blue I have to pick up. So how many are available? 7 are available. So that will be n of a. From 7 I have to pick up 5 blue. If you want you can write this also. How many I'm picking up black? Out of 4, 0 I'm picking up. This is not compulsory, huh? Because 5 already I'm picking up from blue and 0 I'm picking up from black. Now this anyways answer will be, the moment here it is 0 means it is, and value is 1. So some of them will write this or may not write that. So up to you. So because we are done by picking 5, so we want to say that 0 we picked up, that's okay. Whichever way answer will be same because this value is 1. Now calculate 7 factorial upon 2 factorial into 5 factorial. What will be probability? This answer upon this always will reverse. 5 and 5 will cancel. Now you split this bigger number. Sorry, 7 factorial. Then 6 factorial you can split. Multiplications, everything can be made common. 11, 10, 9, 8, stop at 7. So 7 and 7 will cancel. 2 and 2 will cancel. And now cancel the remaining numbers and calculate. 3 3s are 9, 4 2s are 8, 5 2s are 10, and 3 2s are 6. So numerator everything is gone, and then only 2 is left. So 1 by 22 will be our answer. Those who want could have calculated separately this value, and then divided. Same answer will get. Anyone who has not understood can ask. Calculation of combinations you cannot ask now, because that was already done in the previous chapter. Only in terms of probability, something you have doubt of framing, that you can. because nobody bothers to check the recordings. Previous probability second chapter, I had not sent a recording. Today I sent. I was just this checking whether you all really bother to ask or no. Because you all claim that every time I say why I did not attend, you all will always say I will watch the recording. I don't know what you all watched previous class. Yes, second part is what? 2 blue and 3 black. Okay, so there are 7 blue and 3 black. And means multiply. So 3 blue I want. So how many available to me? 7 available. So from 7 I'm picking up 3 blue and means multiplication. 3 black out of 4 available. Sorry, 2 blue, no? This will be 2 and this will be 3. If you add this 2, it should give you 5. If you are picking up 5. And if you add the numerator, it should give you 11. So 7 plus 4 will give you 11. 2 plus 3 will give you 5. So now calculate the value and then divide by the sample space. So this is your n of b you can consider. 4C3. If there is one less value, I told you, this number is one smaller than this, straight away you can write it as 1. So P of B will be 7 factorial upon 5 factorial into 2 factorial and then ulta. What was that? 11C5, no? 5 factorial. Again, 5 and 5 will cancel. And then calculate. 7, 2 and 2, and then cancel out this. Again, 1 by 22 will be our answer. Next one, third one, 3 blue or black. It means what? 3 blue or 3 black. This is 7 blue, 4 black available. So or means there's a plus sign. Okay. Now 3 blue. Total out of this has to be 5. Okay. And this is 11. Now if I'm picking up 3 blue, just check how many options are there. 3 blue. Okay. Or it means if I'm picking up 3 blue, I'm still not done. Total 5 marbles I have to pick up. Okay, I've just picked up 3 blue. Then what will be the remaining? If I'm picking 3 blue, I'll have to pick 2 black. Or what I'll have to do, if I'm picking up 3 black, I'll have to pick 2 blue. So that total becomes 5. So what are the options? 7 C3 means blue will be 7 option available, and 2 black. 2 black means out of 4, or 3 black out of 4, and 2 blue out of 7. So this will be N of C. And then you have to divide by your sample space after calculating. So we'll add this value. OC3 will be 1. Four and 4 factorial will cancel. Two twos are 4 plus 14. 6 5 are 30 plus 7 twos are 14. That is N of C. And then you divide by your sample space. And then open up this bracket and calculate. So that will be 224 5 into 6 factorial. 11 will be splitted till you reach 6. And now whatever numbers are possible to cancel. 5 twos are 10. Then 4 twos are 8. 3 threes are 9. 3 into 2. So 6. 6 threes are 18. No, it's not going in the 3 table. So 2, 1, 1, 2. So 112 upon 33. Into 7 is this. Okay, so that will be answer. You can keep in terms of fraction only. Huh? Okay, 7 table also can go, no? 7 ones are 7, 7 6 are 42. So 16 upon 33 will be our answer. And whatever answer you get, you have to make sure the fraction if you are getting, the denominator should always be bigger than the numerator, because probability can never be more than 1. If you don't practice these calculations, no, then there's no point in doing for exam only. You have to practice this. Second one card is been drawn from the pack of 52 cards. Each of the cards been equally likely to be drawn. So find the probability. Next are the conditions. So what will be a sample space? So out of 52, how many cards are drawn? One card. So 1 means straight away no need to calculate. Answer will be 52 only. The moment this denominator is 1, answer is always this. So that's a sample space. Now, what are the chances? First one, it should be a ace. So how many are available? So one card you are drawing every time now. Okay, so there are how many aces available in the pack of cards? 4 aces. N of A will be 4C1, which will be 4. From 4, if you are picking one, there are chances that one of the 4 aces would come up. What will be the probability? 4 upon 50. So 1 by 13 will be your answer. So 4 aces out of 52. Third. Second one, red card. Red card means how many available red cards in the pack of this 52 cards? 26 cards. If you were drawing 2 cards, no, then this would have been 2. This also would have been 2. And then you have to calculate by using factorial. But now since this is 1 only, straight away it becomes 26. F of P of B will be probabilities divided by the sample space. 1 by 2. Want you can write it aside and keep. Why? Because there were 4 aces. This is 26 red cards. Now this can be either red or king. It's a or. Red card, how many are there? 26 C1. Now or means plus. Now when you're calculating kings, do not make the mistake of writing 4. If you write this, everything will go wrong. Because whenever you are, see, king, how many are there? Always there are 2 red or it could be 2 black. 4 kings, so there are 2 red and 2 black. So out of that, whenever you were picking 26 cards, these 2 red kings were already gone here. So which are the 2 left? Only black kings, because this 26 you have already calculated these 2 red kings inside this. Otherwise this you should have taken 24 red cards other than the kings, and this will be 4 then. Okay, so anyway, this is 26 and this is for the, you write and keep 2 black kings, because these 2 red kings are already taken here. That will be 26 plus 2, which is 28. So probability will be 28 upon 52. Yeah, if you want to write, 2 red kings are already there. So this anyways you calculate, normal calculation. Fourth one is red and king. Now it has to be red as well as a king at the same time. And means it has to be satisfying both. So which is a rare card, which is also a king? There are only 2 cards. That is red. What is that? Diamond king. And a, what was that? Heart king. So that's why there are only 2 red kings available. Answer will be 2 upon probability. I'm writing directly 52 to 1 upon 20. So see the difference. Or means it could be plus. So it could have all the 26 red cards or could have been the black king. Here what they are saying, it has to be red as well as the king. So it, in short, it means what? The red kings they want. And means it has to be both at the same time. So only one, there are 2 cards which are satisfying, that it is king as well as a red card. So that is what the diamond and the this. So only 2 options. Third one. What time you like chemistry? Anyone? What time?
5:30, teacher.
Oh. Third one. A box contains 9 red, 7 white, 4 black. Okay, now from here, 2 balls are drawn at random. Not written this because it might get confused with this B. So now 2 balls are drawn at random. Total you always write here. 11, so 20 balls together. So obviously, first thing, without even going into the condition, when you see the question saying find probability, find a sample space. So what will be the sample space? From 20, you are drawing 2 balls. 20 minus 2. 20 into 19 into 18 factorial. 18 factorial into 2. So 190 will be your answer. That's a sample space. Now we'll come to the condition. The first condition says both the balls are red. Means the 2 balls should be red. So how many options are available? 9. And we have to pick only 2. So straight away answer will be 9 options available from there. And remaining will be 0. It's like 7C 0, and from black we are picking 0. Not required. That value is anyways 1. The moment this is complete, means what I told you, numerator should match this right now. That's when we are picking many balls. Now anyways, out of here, 9, 7 and 4 will give you 20, and 2 plus 0 plus 0 will give you 2. Even if you don't know do this, the moment you get 2 complete here, stop and then calculate. 9C2 will be how much? 9 factorial upon 7 factorial into 2 factorial. 9 into 8, 36 upon 190. So P of A will be, and then again cancel and calculate. So this was about the first condition. Then second condition says one white ball. So one white means what? Now you have to understand this. One has to be white. Are we done picking up the balls? No. We have to pick up finally 2. And one more from the remaining. So what they are putting a condition, one has to be compulsorily white. They don't care which you are picking the next one. So one remaining from, this is done, remaining from red and black. So the remaining could be from this two. Because they have not told the second one has to be red or second one has to be black. So it could be from both also. Okay, remaining out of this. So one white means how much it will be? 7C1 into the remaining one. Okay, one I'm picking up white from 7 white balls. This remaining one could be from this or this. So what is that? 9 plus 4. I'm splitting and writing so that when you're studying back, you understand. Otherwise, straight away you can write it as 13, huh? No problem. This is 13, or you can put an arrow like this and put 9 plus 4. So 9 red and 4 black. So the remaining white ball, remaining one ball has to be picked up from the remaining 13 balls. So one from 7 white and one from this. So total when you add, it should give you 20, and denominator should give you 2, and then calculate. 7C1 is anyway 7, and 13C1 is anyway 13. So probability will be 7 into 13 upon 190. Then you calculate. Any doubts? If you not understand, please ask. Huh? There is no point simply copying and keeping. Which problems you have to understand. No point by hearting, because every time they will not give you the same problem. Third one, both same color. Now what they are telling, same color, so we don't know which could be the same color. If they had said both red, we were sure that both red in the first question. But now when they say both same color, this could be both red, or they could be both black, or both black, white or black. So whatever you're picking should be both red, or should be both white, or should be both black. So if you are picking both red, how many options available? Then of say 9. Or both white means 7C2, or both black means 4C2, or means plus. You can add the answers and then divide by a sample space. Calculate a value. (36 plus 21 plus 2). Okay. 63 will be your answer, and therefore P of C will be 63 upon, I think that was 190, upon a sample space. Don't forget to divide by sample space. Huh? If you keep 63, everything will be wrong, because probability cannot be more than 1. You have to divide by the sample space. And the last one is red and the other one is white. So this is simple. One red and one white out of those two. So for red, 9 options are available. From 9 you are picking up one, and from 7 you are picking up the other one. So that's N of D. So 9C1 is anyways 9. Similar answer you'll get. P of D will be 63 upon 1. Okay, I'll stop here. Continue with the problems in the next class. Those have not